So number 57, we'll get another graph up here. Let's make it bigger. And move it down a little bit. So this is 57. And it says we want to graph the function. This is a piecewise function. F of x is equal to, is this not going to let me write over here? I wonder if it's on negative x. They stole my screen space. Let's do this again. F of x is equal to, I have a bracket, negative x plus 2, where x is less than 0. That really should be over here, right? And the square root of x plus 3, where x is greater than or equal to 0. So it's a piecewise function. Basically, I want to look at these as two separate things going on. So if f of x is equal to negative x plus 2 when x is less than 0. So let's just start at let's say at the point 0. What would f of x be? F of x would be negative 0, right, plus 2. So it would be 2, but since it is less than 0, I'm going to have an open circle there. If x was negative 1, because I'm only for the domain on this top part of the function for x is less than 0. If x was negative 1, my f of x would be 3. Right? Negative 1 plus 2 is 3.
Is it 1?
Follow me? Pardon me?
Is it 1? Negative 1 plus 2?
Well, the function is negative x plus 2. So if I have x is equal to negative 1, then I have negative 1. You follow what I'm saying here?
Mm-hmm.
Right? So where x is equal to negative 1, my f of x is equal to positive 3.
Why is it a closed circle?
Because at x equals 0, this function is undefined. Where x, because it says where this part of the function is only for where x is less than 0.
Oh.
Right? So at 0, it's undefined. I just wanted to get an open circle so I know where I'm starting. Okay? And then I can get another point. So if x is negative 2, then negative 2 is positive 2, plus 2 is 4. So negative 2 would be 4. And I know this is a linear function because I only have x to the first power. And now I've got 2 points. So I can make this into a line. And I have graphed the top part of my function. Now I got to go to the bottom part, the bottom piece. Okay, so where this is for x greater than or equal to 0. So I have the square root of x. I know from my library of functions kind of what that looks like. So where x is equal to 0, my y value is going to be equal to 3. Are we okay with that? You see that? On the bottom function, if I have x is equal to 0, y is going to be equal to 3. So I'm going to have, that is going to be a solid point. Because my domain for this part of the function is x greater than or equal to 0. Okay. Well, where x is equal to 1, the square root of 1 is 1. Plus 3 is going to be 4. So it's going to be right there.
Wait, is that square root of 1 is 1?
The square root of 1 is 1, is it not?
Yeah, but it's not completely 1.
The square root of 1 is completely 1.
How are you going to get a square root of 1?
square root of 1. It's saying what number, when times itself, is going to be equal to 1. Right? So what number times itself is equal to 1?
1.
So, yeah, square root is 1 is 1. You're double checking? I think it's a good idea. It's always a good idea.
I went up to like, I went up to 4. Oh, okay.
So if I want x is equal to 4, the square root of 4 is 2, and 2 plus 3 is 5, right? So where x is equal to 4, my f of x is going to be 5. And you can kind of see already, if you know the library functions inside out, right? You can see already that this is going to kind of take off and go like that. And what is this? This is the parent function of the square root of x
Plus 3.
plus 3. So it's raised up 3 values. Right? Same thing.
There's no transformations on the final.
There are no transformations in the final. No. Okay, so that is that's a piecewise function, and that's how you would graph it. The key to graphing piecewise functions is to look at your domain and just graph them one piece at a time. So essentially, like, cover up the part that you're not doing.
I put it on my card.
No. No. Does that make sense? Okay.